Hey everybody, welcome to Engineering Academy, and in this video I'll be talking about how to finally design your building in SAP 2000. So we have done a lot of things so far. We modeled our building, we defined and applied the loads, then we specify the codes, and we also defined the load combinations. So after doing all of these things, what you need to do is just run your model. Okay, so let's switch to 3D view. Yeah, you can see the deformed shape of the building, and let's just animate. Yeah, as you can see, the building is dancing now. Yeah, that's great. Alright, so let's stop this. This is just a figurative thing, and after doing this, go to design and click on concrete frame design and click on start design check of structure. Alright, so let's switch to XZ view. As you can see, my unit here is Newton mm centigrade, right? So if you don't have this unit, just change it. So let's take this column as an example. So here the number says 1542. So this number is the area of reinforcement that needs to be provided in this column. So we have to provide reinforcement of 1542 mm square, right? If we see the beam, so we see the reinforcement at three places, that is at the edge, at the middle, and at the edge again. And so this is the top reinforcement and this is the bottom reinforcement. So we have to provide a reinforcement of 604 mm square at the top and 355 mm square at the bottom. So that is basically the area of reinforcement that needs to be provided. Alright, so SAP has displayed the area of reinforcement that needs to be provided in different members in our building, but we cannot use these values right now because in the beginning, while we were defining the section properties and frame section, so what we did was we had I'll show you. So we have given this size for beam 350 mm, that is depth, and width 230 mm. So same goes for the column. We gave some dimension, right? Okay, so we don't know whether or not our building is safe with this. Check it first, and if the members pass that check, if the members pass that check, and after only that we can use these values. So for checking, go to design and click on concrete frame design. So alternatively, what you can do is that you can just click on this icon over here, and you can see that same menu right here, and here it says verify all members pass. So click on this, and it says that all concrete frames pass the stress capacity check or are designed. So one of the biggest mistake that the designers do is that they just check up to this point only, and so once the members have passed, they just use these values. However, there are a lot of other things that needs to be checked before you can actually use these values. So I'll describe all those things that needs to be checked one by one in this video. Alright. Alright, so SAP has displayed the reinforcement details in mm square, that is area of reinforcement. So if you want to see the reinforcement in percentage, you can also do that. Just click on this icon over here. So this is basically going to design and concrete frame design. This menu you can get from here. Alright, so click on this icon and click on display design info, and here you can click on rebar percentage and click OK. As you can see, the SAP has displayed the reinforcement in percentage value. So you have to check if the reinforcement falls within the maximum and minimum range, within that range. So I'll make a separate video for all what is the maximum and minimum reinforcement for any member. Alright, so you have to check that thing. Again, you can just go to display design info and click on longitudinal reinforcing, and you can again display the reinforcement in mm square. So after checking the rebar percentage, the next thing that you need to check is the column PMM interaction ratio. For that, again, go to this icon and click on display design info and click on column PMM interaction ratios. So here this P indicates the axial load on the column, and M indicates the moment in X direction, and M indicates the moment in the Y direction. So this is basically the check of the column whether or not our columns are safe. Click on OK. Alright, so you can see the color of the column is orange right now. So if the color of the column is this red, it means that the columns are over stressed and we have to increase the size of the columns. And if the color of the columns is any other color than this red, one of these colors, it means that our columns are safe. Same goes for the beams. Alright, so as you can see, so let's check on the other grids, and you can see that all our columns are safe in PM interaction ratio. After checking PMM interaction ratio, the next thing that you need to check is beam column capacity ratio. So let me first explain what it actually means. So we know that at any junction the beam must be weaker than the column. So that is basically the concept of strong column weak beam joint. Alright, so this needs to be satisfied for all the junctions. So let us consider this junction as an example. So if this beam fails here, then only this panel, only this panel will be affected. Let us see in XY plane. So this beam is this beam. So if this beam fails, only this panel or this panel will be affected. However, there will be no effect on this slab and this slab or this slab, right? However, if this column fails, this entire floor will collapse and the floor above will also collapse. So at any junction, the beam must be weaker than the column, or the column must be stronger than the beam. Alright, so first checking whether or not this thing is satisfied, we need to again go to display design info and click on 1.1 beam column capacity ratios and click on OK. Oops. So let's click on this window and just again do the same thing, display design info and click on OK. Alright, so let's change it to 3D, this one. Alright, so as you can see here, there are different values corresponding to different columns. So for a column to pass in beam column capacity ratio, this value must be less than 1. So here you can see this is less than 1, this is less than 1, here also less than 1, but here it's greater than 1. In this column also it's greater than 1. So what we do is that we increase the size of these columns. So these columns are top story columns, right? So if we increase increase the size of these columns, we also need to increase the size of these columns as well, because you cannot have smaller size columns at the lower floors and larger size columns at the upper floors. So we select these columns and again we select these columns and we just check other grids as well. So here in this grid everything looks great. Yeah, this grid is fine, and let's check other grid, and here also all the columns are safe, right? So so here these columns have failed, so we select columns as well as the columns that are below them. And alright, so this much. So we unlock the model now and click on OK, and after that go to define and click on section properties, frame sections. So what we do is that we now click on add copy of property, and so I name it column 400 and change the size of the column. So I define a new column, so it's a 400 by 400 column, right? So click on OK and click on OK again. So I define a new column. So what I need to do is that I need to increase the size of these columns, right? These selected columns. So I go to assign and click on frame and frame sections and click on column 400 by 400. So what this will do is, so it will increase the size of this selected column from 350 to 400. So it will assign new column size. Alright, so click on OK. So now we got a new column size, and again we run our model and click on run now. and again we now we design, and we display design info and click on 1.5. Alright, so these columns look pretty much safe. However, this one is at the edge of not being safe, right? So it's like this column again, and let's check the size of this column. So it's a 350 by 350 column, so we'll increase its size again, right? So let's see other columns. So all the columns in this grid are safe, and in this grid also the columns are safe, and here also they are safe. So we got only these columns, so this column that is not safe, right? So we again unlock this model and go to assign, so frame sections, and click on, so it's a 350 by 350 column, so that is why I am increasing the size to 400. And again now we run our model. And now again we design, now let's see display. Yeah, so now it's safe, so other columns are also safe. Now let's check other columns as well. Alright, so all the columns look safe, right? Okay, so this is how you check beam column capacity ratio. Make sure the values are less than 1. After checking beam column capacity ratio, the next thing you need to check is column beam capacity ratio. So that is basically the reverse of beam column capacity ratio. So again, go to display design info, and here you click on column beam capacity ratios and click OK. So this value must be greater than 1.1 for all the columns. And here in this grid all the values look greater than 1.1. Here also all the values are greater than 1.1, and here also they are greater than 1.1. So all the columns are safe in column beam capacity ratios. Again we check in joint shear capacity ratios, and these values must be less than 1. Alright, so yeah, they're pretty much less than 1, and yeah, all the values are just fine. Last but very important thing that needs to be checked is the story drift. Alright, so story drift is nothing but the displacement of a story with relative to the story above or below it. So that is the displacement of the story after the application of the lateral load. Alright, so for this let us first remove these things and click on clear display of assigns. Now we also change the view and click on standard and click on OK. Alright, so after that go to display and click on show deformed shape, and here is like EQX, and rest things are as it is, and click on OK. So as you can see, the entire building has shifted towards right after the application of the EQX load. So make sure that your display or your elevation view is XG view, right? Only that you can see this view for now. If you want to see the original position of the building parallel with the displaced position of the building, just go to display and click on so deform shape, and here click on just check this wire shadow thing and click on OK. So you can see the original position of the building, and this blue line is the displaced position of the building, right? As you can see, this story or this slab has shifted or displaced by this amount, right? So we need to so this amount or this displacement must be within the limits. So if it is beyond the limit, you have to increase the size of the columns. All right, so IS 8093 2002 says that the story drift must be limited within the value of 0.004 times the height of the floor. For example, if the height of this floor is 30 feet, just for an example, so 30 feet times 0.04, so story drift must be limited within that value. All right, okay, so for checking by how much this floor has shifted or swayed, we just click on this joint and just right click here, and you can see there is a translation. It says 9.375 mm, right? It means that this slab has shifted by 9.375 mm, so our unit is mm, right? Alright, so if you do 0.04004 times the height of this floor, you'll get that this translation is within the limit of story drift. Alright, so our building looks safe in story drift in EQX load. So after that, just change your view to YZ view, and again go to display and click on so deform shape, and here click on EQY and click on OK. Alright, again click alright, so just click on this joint and right click here, and as you can see the translation here is 9.155 mm, right? So okay, also this floor looks safe in story drift, and you can also check these values as well. So 6.20, that's safe. So you have to do the calculations, right? So I have already done the calculations and found that they are safe, and you can also check these values, right? Okay, so this is how you check the story drift, and make sure that your building is within the safe limits. And there is yet another thing that you need to check, that is the drift ratio. If you want to check the drift ratio, what you need to do is that you just have to subtract the story drift of this floor minus this floor divided by the story height. For example, you see the story drift here is 9.155 mm, right? So you have to do 9.155 minus story drift of this, that is 6.2097. So 9.155 minus 6.2097 and divided by this story height, and you'll get the drift ratio as well. So it also needs to be checked whether or not our drift ratio is within the limits. Alright, so I think all our members have passed. Now what we do, we just get the our longitudinal reinforcement, and you can see now. So now you can use these reinforcement values directly and just detail your columns and beams. For example, if you need to detail this column, you need to take 1371 mm square, and you can use any number of any combination of number of bars and the size of bars. So I'll make a separate video on how you can detail your beam, column and slab by taking the reinforcement values, and I'll also make other videos how you can manually design beam, column by taking the values of the SAP analysis. Alright, so this much for this video. Hope it was helpful. Thank you for watching. Take care.